Hi everybody, my name is Mike Elkin. I'm a production engineer at Facebook Dublin, and what I'm here to talk to everyone today about is having focal impact using the service pyramid. So the service pyramid is a framework that we use at Facebook when we've got new engagements or when we're doing road mapping sessions to identify essentially the most important areas amongst the litany of projects that we can actually have impact. So our journey today is going to be talking a little bit about buildings as a service, because data center buildings are actually services too, just like ads or a search, networking, MySQL infrastructure. These are all things that are services, and buildings are kind of like a service. Then we'll talk a little bit about the hierarchy of needs, and then go into the actual service pyramid framework itself. And then I'll close out talking a little bit about our actual data center engagement at Facebook, where we've been applying the service pyramid to great effect. So about a little over a year ago, we went and decided to actually engage with our data center organization from the production engineering standpoint. And to give you some context on just the scale we operate at, this is not actually even the complete list of our origin data center locations. It's actually another location that doesn't fit up there because the default font size was just too big, which is in Nebraska. It was recently announced. This is basically all of our announced and current data center locations. So when people think about data centers, most commonly what they'll think about is servers and networking. But in my space, what I'm actually thinking about is the two fundamental things that the data center is actually providing, which is essentially the power and the actual cooling functionality. So on the left-hand side, this is actually part of our electrical distribution network. Essentially, that helps bring in the high voltage power grid down to essentially lower voltages that we can actually put into a power supply. On the right-hand side, that's actually a photo of one of our open compute fan array walls, essentially helping bring in the cool air into our data center environment. So when we started this engagement, we pretty quickly realized there was a lot of work to be done. We had like a very, very long list of projects, and so what we had to do was to figure out some mechanism to actually whittle that down to the most important things that we could be working on so we could attack those very tactically. So to have that, we actually need to have some sort of framework, and we need to have a basis for that framework. So in the 1950s, there was this guy named Maslow, and he built what he called the hierarchy of needs. So you've probably seen this. I know memes are pretty hot right now, and there's a whole meme around this. But basically, you've probably seen this before, but every layer, essentially, to get to the next layer, you need to have the layer previous being very, very solid. That is, to go from physiological to safety in your hierarchy of needs, you need to have very strong physiological status. So that actually becomes a really great way for us to think about services, because with services, we need to have a mechanism or like a path to figure out where we are and what we need to do to get to the next level. And so we built out our service pyramid, which essentially becomes a maturity assessment at the onset. We've got 6 different layers in the actual service pyramid, and we can use this to actually start flushing out the actual process of figuring out where we're at, where we need to be. So we start off with the very, very lowest layer of the service pyramid, which is essentially the hardware and provisioning steps. So with hardware, we should have a very clear understanding of every single asset that we have. Now, it doesn't really matter whether it's physical or virtual, but we should have a way to actually track and understand all of the information about these assets, where they are, their location, locality constraints, attributes like memory, CPU, disk, and we should also know their actual hardware types. Now, knowing where all of the actual equipment is, we should also have a good understanding of our provisioning process and the operating system. We should have an understanding of how to configure the operating system, how to consistently and repeatably take that operating system installation and bring in a full foundation that we can then later deploy our services on. That's really important, because without a consistent and repeatable foundation, we won't know the actual the outcome state of a server when it's been through the provisioning process. So once we've got our servers provisioned with an operating system on it, it makes sense for us to actually have some server monitoring and understanding its life cycle. Because every single physical server pretty much is going to have an actual hard disk. And hard disks can fail, and that's a problem. This is something that we should have one consistent set of monitoring for across all of our infrastructure. We don't want every single team to be worrying about, from a service perspective, whether a hard drive is good or bad. We want to have that consistent monitoring to actually go detect these hardware faults and escalate them essentially. And if we're going to have the alarming consistent, it makes sense that we have a remediation framework that can take those alerts for bad hardware issues and actually process them to go and figure out, is this a fixable problem? Is this something that an actual on-site technician needs to go and look at? And we should have something that actually can take that alert, figure all that stuff out, and send it to the right queue. And something that is probably a little less known is actually just how important understanding your actual asset lifecycle is. What I mean by that is essentially we should have the ability to track an asset from the point at which it's actually been ordered all the way to it arriving on our landing dock, to when it gets actually racked and stacked, going through the initial provisioning process, and then the actual status of that asset for most of its operational life cycle coming into and out of service and going into and out of repair, because you have servers going from hot to cold, you've got servers having hardware faults that needs to be managed, and eventually that server is going to actually go to a decommissioning process. Every server eventually has an end of life. We can start to use this life cycle to start optimizations on being able to assert certain things, like we should not have servers that are provisioning for a certain amount of time, or for example, we should not escalate any alerts for a server that's in repair. We know a server's in repair. We don't need to be telling everybody that the things on it are broken. So once we've got our actual consistent monitored server platform, we can actually start looking at the service space. So we should have monitoring for any service that we're going to be deploying, and at least initially one of the things that we should be doing is just doing very black box testing of the service. You don't even necessarily need to have insight into how the application works. We just need to know that it exists. We should be able to answer very simple questions such as, is the process running? Is the port listening? Is the port responding to requests? Are we getting exceptions there in the logs? Is it happening in a reasonable time frame? So now that we've got monitoring of the service, we also need to have a consistent mechanism to know how to actually manage that service. We need to have installation steps and knowing exactly what environment settings we need to have, whether it's configuration files or dependent packages, things like that. We should know how to invoke the service, what arguments we'll actually have to pass in to this service. We'll also have to know, of course, because we don't just ship a service to production once, right? We actually have to manage that service and upgrade it and restart it over its lifetime in the production environment. So we should have consistent steps to actually upgrade and restart the process. And of course, we should also understand how to actually stop a process gracefully, because we don't want to have any issues where we're bringing down a service and maybe missing actual data rights, or potentially increasing the error rate for end users. We don't want to have those problems. So now that we have our capability to repeatably go and take a single server, monitor it, and actually place the service on it, we can start to think about scaling that service. Going from 100 to 200 nodes, since all of these previous steps are pretty well documented and scripted and automated, we can scale up pretty quickly. And since we also know how to do this, we can start to consider what disaster recovery might look like. Going from an active standby configuration, maybe having active, thinking about shadow tier deployments where you might not necessarily be actually doing database writes, for example, but still doing performance timings on that. And we can also look at the actual advanced service monitoring. So this is where we start to examine the actual internal state of our service. We should not just know, is the service up or down, we should know how well the service is operating. We should have a good understanding of the attribution of how well the service is operating, being able to track which external dependencies we might have with different performance metrics so that we can start to very quickly triage issues whenever things occur. So once we've gone and got a good understanding of our actual service, we can look at the actual performance tuning of that service. Because we can understand, right, like this particular endpoint is having problems or something's going on in this particular area, we can identify that as a user-facing metric and start to improve the performance by finding potential algorithms or going and working with dependent services to actually make the end user experience better, because at the end of the day, the most important performance fixes that we can have are going to be ones that are removing bottlenecks and actually affecting the end user experience. Doesn't matter whether it's an internal customer or whether it's like an actual end user on a phone somewhere, the actual overall performance is really important. So since we have all this understanding of how well the actual service is functioning and how well we depend on other services, we can start to do projections. We can look at the actual capacity planning and forward-looking methodology, overlaying information such as user growth, user projections for different parts of the world, looking at upcoming features that are actually happening, and we can use that to examine what would it take from either a project or a capacity perspective to get that 90 kilogram projectile 300 meters down the road. So at the very top of the service pyramid, we finally reach the 1% stuff. So the 1% stuff is that weird stuff, right? Start thinking 99 percentile, P99, 9, P99, 99, 99, 999. So imagine a case where an end user goes and reports a problem, they couldn't log in or something like that, and we're able to go and take that report and identify that we have an increased error rate for one particular relevant endpoint. Then we can go and look at all of the metrics around that endpoint, realize that this increased error rate is actually being attributed to one single server. And interestingly enough, that one single server, as we continue to dive in and deeper in the stack, we can figure out that on this server, there's one particular physical core that when given this one operation is giving us the wrong bits. And this kind of thing can actually happen at scale, and it's something that can be very, very impactful, because at this point, your monitoring should be so amazing that you can actually start to detect problems that other people don't even necessarily know they have. So you as a team can be very forward-moving inside your actual company. Now, a lot of these exercises tend to involve shaving lots of yaks and diving into rabbit holes. Not all of these investigations are actually going to be really, really fruitful. But when you do actually strike gold, you can come up with very, very strong cases to fix huge issues across your actual infrastructure and get really great blog posts. So one big risk with the service pyramid is when we start to actually do custom tooling very, very early in the actual pyramid. Because in the ideal case, at a minimum, the bottom layers we should all have consistent tooling for, right? We don't want to have anybody just taking any kind of hardware and throwing it in the data center. We want to have specific known hardware types. We don't want to have 15 different provisioning processes. We want to have one provisioning process that everyone knows and can manage. Similarly, from a monitoring and lifecycle, we don't want to have tons of stuff out there. We want to have as few things as actual possible. And at the top layers of the stack, that's where we start to get into cases where having custom tooling is more acceptable. In the ideal case, across all of our services, we have most everything using shared tooling, because that helps signify that as a company maturity model, we're actually doing pretty well. But realistically, you'll probably have to do some custom tooling at the top layers for your service. So when we actually kicked off our engagement with the data center organization at Facebook last year, the very first thing is we went to the service pyramid. And the service pyramid was extremely confusing at first, because when we're talking about the data center, right, we're talking about very specialized equipment. We're talking about, MSBs, we're talking about variable fan drives and all sorts of things where we don't really have like a Linux operating system that we're deploying onto these devices. And the service pyramid is using all of these words, server and operating system, and it was really hard for us to manage at first because it didn't really seem to apply to us at all. But when we really looked at it, it's actually extremely applicable to us, because it doesn't really matter that it's a server. What really matters is that we know how to actually monitor that thing effectively. And it really matters that we know how to provision it consistently and repeatably. Regardless of what kind of actual device it is, we actually can really just use that mechanism. So we figured out pretty quickly that we actually have two different service pyramids in effect. On the left-hand side, we've got a more typical looking production service. So these are our services doing things like our asset tracking, our data processing, taking information, sending it to like our business analytics team, and doing the actual remote monitoring. And on the right-hand side was where a lot of the interesting stuff was happening. And that's the actual building management system itself, which runs the actual building, the electrical equipment, the mechanical equipment. And from there, what we realized is that the service pyramid is not prescriptive. It's actually more like a guidance. It guides you towards the areas that you should be working on, but you don't have to follow it exactly. So when we first came into our assessment of the overall maturity in the data center space, what we quickly figured out is from a hardware and a provisioning standpoint, it was just really bad. It was extremely ugly. We didn't necessarily have good control over the kinds of hardware we had. We didn't know how they actually were configured and managed. From a monitoring standpoint, life was a lot better. We'd gone out and actually purchased some third-party integration software to help us with monitoring, and the building managed the system at the end of the day. It was doing an okay job, not great, but it was at least keeping us running. And from a service monitoring standpoint, it was a really tough time. Most commonly, people would come to us and tell us that stuff was broken, which is usually indicative that you're having a really bad time. So if we're getting alerts way after the people are coming to us, that's a really bad place to be in. And the top layers, quite frankly, to us, they just didn't even exist. We had no capacity or planning to actually go and figure out like how this stuff would even work. It was all ad hoc whenever somebody absolutely critically needed something to go and do any investigations there. And so we figured out that very quickly, we're not going to put any effort invested into the top tiers because, of course, we need to actually solidify the bottom. And you'd think that the very first thing that we would do is actually jump in and figure out all of the hardware types we have and get provisioning. But in reality, that was really intended for a server life cycle where we've got tons and tons of servers, and you're typically bringing them in and out of a data center every like 2 to 5 years. In the data center space, when we have a construction happening, typically that equipment is actually going to go and sit on the wall, like you go and you just stick it up there, anywhere from like 10, 15, 20, 25 years. The life cycle of most of the industrials equipment is actually a lot longer. And so for us, we didn't even necessarily have a lot of opportunities to test what we would potentially be doing. So instead, we actually focused a little bit higher in the stack. From there, what we realized is that we really had to be delivering impact quickly. In our engagement, we're a brand new team. We're the production engineering group. People had heard of us, but they didn't actually know what we did or how we worked or what value we added. So it was extremely important to us to very quickly figure out the most important things that we could do and set a clear set of goals. So what we decided was to completely skip that bottom layer and focus very heavily on making our monitoring of the actual equipment great. We didn't want this to be a third-class citizen in our infrastructure. We wanted all of the device monitoring to be first class, to know things very, very quickly, to have good monitoring, clear monitoring of all of the equipment that we had. And of course, we don't want to be woken up in the middle of the night by somebody else telling us that something's wrong. We want to be able to sleep comfortably at night, and we want to know that when an alert comes in that we're catching it before anybody else. So we wanted to at least take our service level monitoring from being bad to at least acceptable so that we can sleep comfortably at night. Now, there is some inherent risk with taking this approach, and at least I do stand by it, because the provisioning was still bad after we set our goals and executed on them. The provisioning was, quite frankly, terrible. And so in a future road mapping session, what we did was reinvest at the bottom parts of the pyramid to make sure that we can close those out. Another really important thing when you have any new engagement is to make sure that you're speaking the same language. And not just necessarily that you're speaking the same language, but that you have the same understanding of the words that you're using. So, for example, if I go and I start talking with a controls engineer and I say, oh, there's an alarm that fired. Now, what I really mean is, oh, there's an alert from our monitoring system with some degree of criticality that could be minor, could be really, really critical, and it's gone and it's in our system and somebody should probably go ahead and take a look at it. But when a controls engineer would hear the word alarm, they would think life safety problems. They're thinking someone's life is in imminent danger, because these are industrial environments, right? Really high voltage equipment. These are actual problems they're facing every day. And so it's extremely important that we have the same understanding of all the technical verbiage that we're using in our day-to-day. And you, as an engineer, when you're in any meeting, should always feel comfortable to actually sit there and raise your hand and say, I have no idea what you're talking about. I don't understand exactly what you mean by this. Can you please explain it to me? Because quite frankly, there's probably a lot of other people in the room who don't understand either, and they're just being quiet about it. So we, as SRE and production engineers, really need to be advocates here for ourselves and for everyone else. So the service pyramid was built for a software engineering engagement. They had no, I think, intention, whenever it was first written, to really do or behave the way it has in our data center and facilities engagement at Facebook. But when we really stepped back and looked at it, it makes just, quite frankly, a ton of sense for how we should actually be planning the work that we're doing, prioritizing that work, and executing on it. So I'm really happy to say that it worked extremely well for us, and I hope that you can take this knowledge yourselves to have focal impact. Thank you.